This conference will now be recorded.
I need to get rid of one of my. How do you exit?
So it's okay now.
No, I'm in twice, so I need to get out of one of them.
Oh, okay.
I can't see a.
You can leave. I think you can leave.
Oh yeah, there is.
Okay. Are you still there, Paul?
Okay. Yeah, I'm still here.
All right, cool. All right, let's crack on.
Yeah, sorry about that. I don't know what happened there. Where were we? Okay, so just to recap with scalability. Yeah, scalability. Scalability allows businesses to increase their hardware or software based on the amount of traffic that they're getting in. So let's say that we have a website and we have an average of 100 users come into it every day. So we've built our system, we've got the right server to cope with up to 150 visitors a day to our website, all interacting at the same time or at separate times, but our server can quite comfortably handle 150 people per day. Then we reach my favorite time of the year, the Black Friday week, and there we put on a huge sale. We give 50% off everything on our website, and then we do a lot of advertising, and then we anticipate that we are going to get 300 visitors a day to our website. Now we know that our server cannot cope with anything beyond 150. 150 is its maximum. The bandwidth is restricted. The server can only process so much information at a time before it reaches capacity. So we have two options. We can either buy another server and duplicate what we have on one and put it on the other and split the traffic to go to one or the other server. Or if we're in the cloud, we can simply set up what we refer to as auto scaling, so that once one or two thresholds are met, so let's say we have a CPU, computer memory usage of a processing unit of 70%, it will then trigger another server to automatically start up and start taking some of the additional traffic. So that's what we mean by scalability, that the increased throughput or the increased number of requests comes in, the system will take care of the expansion of our server and service. And then as that decreases, it will turn off the second server or the additional service until it's down to a scale which is normal again. Does that make sense? Does anyone have any questions around scalability? Yes.
Okay, let me just add something quickly. I will just try to break it down as much as possible. So basically, we have server machines, physical machines, all right? And each server will have a maximum amount of memory on it that you use to run your application, which is the website or your mobile application. And if you're going to have that in your local server room, and you are anticipating an increased traffic, number of people coming to your website, like Facebook, for instance, you might have to buy another machine so that you can increase the memory. All right, and this will be done manually. But Paul is talking about auto scaling. But with cloud computing, they have several machines that might just be there lying idle. But whenever there is a need for them, it will automatically spin off another machine. You don't need to go and buy another machine and start manually configuring all of this. It spins up, it copies the existing application database and everything, and then you can have scale of number of people that are using your application at that same time. And whenever that need is no longer there, it drops. And Paul give an instance of Black Friday. There are periods whereby people are more on the web, and there are periods whereby people are less. So it will be auto scaling, and with that, it reduces cost automatically. All right.
Can I add something, please?
Yes, go ahead. It's good. It is open for us. Yeah. Thank you.
Yeah, like I know scalability is a non-functional requirement when you talk about app development, and in a layman's term, is more like that function that helps to either increase or reduce depending on the capacity of users for a particular application or a particular like you said a cloud. So if the number of people using the cloud at the same time increase, then the scalability factor increases to accommodate the number of people using it. Then when the number of people reduce, it automatically reduces. The scalability also reduces. So in layman's term, it's more like an automatic way of either increasing or reducing capacity of a particular system.
Yeah. And another way to look at it, if we're talking about layman terms, is if you think about when you're driving a car, yeah, the amount of petrol consumed is dependent on how much pressure you put on the accelerator. So the harder you push down the accelerator, the more fuel you burn to go faster. And as you ease that off, it reduces the amount that's burned. So it's a really good example to think about.
So
I'm gonna. Yeah, sorry. Go ahead.
No, I'm done.
Oh, right. Okay. But thank you for your contribution. That was really, really good to get another perspective from it. Low latency. Does anyone know what low latency is? Latency with regards to computer networking is, how can I put it? It's a way of describing how much time it takes for a data packet or request to travel from, let's say, your laptop to the BBC website. Okay, so there's it doesn't happen instantaneously. It's not like flicking a light switch. You'll often notice that when you're typing in the URL bbc.co.uk, it takes some time for the page to load. Okay, so latency is just that length of time it takes. Now that could be down to a number of different factors. It could be down to the fact that the proximity of your laptop to that server that houses that address is further away than maybe my one. It could be down to the fact the number of people trying to access that same website at the same time. It could be that the way that they're managing the traffic flow in and the way that they've built the web pages, takes time on how it's loading. Not going to go into too much detail on that, but that's where development and when product design can really play a part in trying to do their part in reducing that latency to a certain degree. When we look at page load speeds and things like that. But in computing of any nature, whether it's cloud or local, even when you're starting up the Word or Excel application on your thingy, time is of the essence. It's always of the essence. So the essence is always to try and give the end user the content that they desire as quickly as possible.
Yeah.
Okay. Okay. I was just going to go on to guaranteed performance.
Yeah,
so the other advantage of cloud networking is that the onus of uptime, so availability of the service or your website or whatever it is taken off of you, and the onus is on the cloud provider. So in this instance, we could be looking at Azure, we could be looking at AWS, Amazon Web Services, or cloud, Google Cloud. The onus is on them because they are supplying the infrastructure, the platform, and in some cases, the actual application. So they're the ones that are responsible for guaranteeing that the network is available at all times. It's no longer your responsibility. So a lot of these companies will guarantee a 99.9% availability time. And that's, no one will ever give you 100%, so never expect 100%. I have the same argument with my CEO all the time. I will never promise that person the hurt 100%. So every company will guarantee 99.9% to give them that margin of error. And the reason why they can do that is because they have a vast network of servers throughout the globe in different regions that will take the load should there be a failure somewhere else. So it's important to understand that you don't own any of the servers or infrastructure up in the cloud. You're just renting that space, and it's at to guarantee 100 or 99.9% performance and availability. They have they are able to move your, let's say, your product or your software from one physical device to another to ensure that you have a 99.9% uptime. Extensible management. Again, we touched on this before. So we're talking about upgrading, administrating to a certain degree the hardware and the underlying software that's providing these this platform or this infrastructure. So whereas before I used the example that the IT team of an organization used to be vast, now that can be, you know, down to 1 or 2 people that are managing, you know, things like laptop problems, and not so much with the web server problems that used to come. There are still companies that do have their own web servers, but the large proportion of them use the cloud services because they don't have to worry about upgrading security software, making sure that servers are maintained, and that in some cases, some licenses, underlying licenses are maintained and purchased as and when required. There is still some responsibility on the people that are using the cloud services, that they do have a responsibility for anything that they build and therefore any subsequent licensing that they need. But the majority of that maintenance is done by, and management of the hardware is and other things is done by the cloud provider. Self-healing resilience. So as I said before, guaranteed performance and everything kind of touched on that. They must be available 24 hours a day, 7 days a week, 365 days a year. They often say that there's several theories of thought here. One of them is to fail often. So if you have how can I put it? Maybe David, you can jump in a little bit on this one, but the way that I would describe it is, if something fails, you can just restart it. That's the quick option. There's also something called chaos engineering, which basically follows the logic that if you do have a failure, it will just strip down the environment, and then it will rebuild it and restart again. And it doesn't do that anytime there's a problem. It will periodically do that every 5, 10 minutes or an hour, or every 2 hours, whatever you set it. And that's to ensure that that everything starts up as a fresh. So there's no caching. It clears out all the cache as it does that.
This goes back to like your local machine when it's tired and sometimes it wants to reboot. But with cloud, whenever a machine is tired, another one gets spinned off immediately while that one reboots and resets. All right. So you still have that guaranteed 24 hours a day, 7 days a week availability of the application. Now, I'm going to round off this particular slide, and I'm going to run it off in a way that it makes more sense to PMs, to BA, to testers. All right. Just as Samuel said the other time about scalability, both of these items here moves to the non-functional requirement. Okay, low latency, for example. For a non-functional requirement, you want any application you access to return data within 3 seconds. All right, and with cloud computing, because there are multiple data centers scattered around the globe, if you are in London and your the website you are accessing, they have a data center close to London, it will redirect you to the data center that is close to London, the cloud that is close to London, because with that you get your request and your response will be quicker. It will not redirect you to somewhere in America whereby it will take you an additional 2 seconds. Okay, so when the BA is writing requirement, non-functional requirement, he or she will be looking at, okay, you want this application to return data within specific maximum 5 seconds. So now the infrastructure team, they will now look at how they can access the closest data center or the closest cloud so that that requirement is met. Obviously, the PM also will want the application to work quicker. It's going to be part of the acceptance criteria or the product description. For the tester, he will test to ensure that when he goes through the network, there are various tools for non-functional testing. They can now use those tools to check how many seconds did it take me to return the data. Guaranteed performance, obviously, that means that application will be there and will work continuously. With cloud computing, if one data center is down, you can always access another cloud, and then you have access to that application. Extensible management. Now, still the same thing, multiple clouds, multiple data center. If there's any upgrade in one data center, another data center can be redirected. So let's say, for instance, the closest data center to London is they're doing upgrade. Although you want your application to return in 3 seconds, because that data center is not available, the best next thing is for them to redirect you to a data center that might take you longer, but at least you still have access to that application, rather than going on there and you keep seeing spinning stuff, or the application will not be available. So that is my own summary of this in terms of how it affects you. Okay, so I'm just going to continue now, Paul.
Yeah, go ahead.
All right, up to you. So this is just an infrastructure image of the cloud. Paul, if you want to say something about all of these images here.
Yeah, so this is just a visual representation of the cloud and how you can have some elements outside of that and just have just your basic infrastructure in the cloud. If you expand that cloud out more, you can have all of that in the cloud as well. So your data storage, your services, and your applications can also be up there. I'd like to give you an example of how I actually use the cloud, if I may. So
yes,
I
please.
have an application. Okay, I have a number of application services and data stores that are all sitting on the cloud. So I use infrastructure as a service, software as a service, and platform as a service.
Mind you, this is your current, what you do currently.
This is
So
what I do.
Yeah,
I have
with Azure.
Yeah, with Azure. I have everything hosted in Europe, and then I have a distributed services around the globe in different regions. So that's in Australia East, North America, which includes Canada South Central, or Canada Central, should I say, US South Central, US East and US West. I also have North Europe, Southern Europe, East Europe and West Europe. Within each of those regions, or data centers as they're often known, I have a number of different services. And those services are many in each region. And that's as part of my scalable offering, they're permanently up and running, and they can run from one single instance in a region to many instances within that region, depending on the amount of traffic that we have coming in from the surrounding areas. If one of those regions is reaching their capacity and that the latency in getting a response from one of my services exceeds 2 milliseconds, or no, sorry, 1 full second, which is 1,000 milliseconds, then that request is diverted to another region or data center as it's known, which will then process the request coming in and give the valid response. Any questions?
Can you just
Thank you, Paul. Okay, go on.
Can you just break down what cloud computing is in a layman's term? Because I'm finding it difficult to understand.
Okay. Cloud computing.
Okay.
Sorry, go on, David. You can.
All right, let me just answer this. So, are you aware of most banks those days having their server rooms?
Yeah.
Okay. Do you know what is in the server room? So their machines, isn't it? Their computers, not those computers does not have screen. They are just servers machine. If you look at this cloud, you can see these 3 machines here. These are servers. They don't have screen at all. All they have massive memory and processor. All right, that processes data. Data are images, text, videos, document. All right, that's what those machines are there for. So traditionally, each company will have its own server room. They manage it locally. All right, and then whether they are using it or not, it is there running. But with cloud, instead of having those physical infrastructure in your machine on your machine in your premise, it is now moved to a data center. Cloud is technically the data center. A data center would be a physical location, like a big warehouse, where you have bigger server machines running processes. All right. So that is technically, or that is in a layman terms, that is what cloud is. So instead of you managing your server room yourself, you can either rent those machines owned by some of the top businesses and then make use of it. Run your normal business online. All right. Or we'll get to that point whereby we talk about infrastructure, platform, and software as services. But they will run it as service for you. And you know what service is? You do something for me, I pay you. All right.
All right.
Does that make any sense?
Okay.
What will add to it?
AWS is an example of this.
They will not know AWS. We don't want to go. I don't want to go into technical first. When we get there, we'll talk about AWS and break that down. But I want to be sure that you get my explanation. That is key. If not, going forward, we might not be hitting our goal here.
Yeah, I understand it. I understood what you said
Right.
now.
Okay, great.
Quick question. This shouldn't take long.
Okay.
Paul, when you were explaining, you mentioned something about a host. When you were using what you were doing now as an example. I think you said the cloud was a host in another country. So I didn't really get that, as in when you said sitting as a host, and then you have other data servers around other countries. So what's the one that is as a host? Is that the cloud as well, or is that something different?
No, I don't remember mentioning the word host, but the host is the same as what it means in today's sense. So the host is the physical or the domain.
Paul, I knew where you were explaining that. I can come in quickly.
Go on.
Okay.
Go ahead.
So what Paul was saying is that we have access to different clouds, different data center around the globe. There is one in do we have any in London or in not it's in Ireland, isn't it?
Well, it is, yeah, physically. That's the North Europe one.
Yeah, okay, we have the North Europe one. Then which other one? The one in Australia?
Australia, and then there's
in America, we have how many in America?
3.
Okay, so these are we counted 5 cloud, Yami. So these are physical location, physical machines, but we have access to any of them because our business runs globally. For people in America, if they are accessing our application, the application is hosted on the cloud. It's not hosted on our premise. That is what we're talking about host. It is where your application, your data storage, and your infrastructure sits. So the people in America, they are redirected to the American clouds or data centers. People in Australia, they are directed to the Australia data center. With that, we cut down latency. And Paul made mention, if someone in Australia makes a request, I wanted to do a demo with web application. Maybe I'll do that later. And the response does not come back within a second. They will redirect that person request to another data center, and then that data center will take care of that job. I know some of these words are technical, but I think I will do a demo and show you guys physically what that means, request and response. And also, Paul was using the word instances. I wanted to say, okay, can you explain what instances are? But you guys are going to watch this again. Whatever, some of the things you don't understand or you don't really get immediately. I hope you guys are taking notes. At least you can quickly do an additional research as well. But Yemi, I don't know if I have answered that question a bit.
Yes,
fully.
Yeah. Now I get it. It's clearer now. Yeah.
All right, great.
Hi, David. Isabuchi, can I quickly ask something? I think it's.
So can we hold on first? Yeah. Sorry, Abuchi. Sorry for cutting you. Yeah. I think write down your questions. Note your questions as we are going on, so that we can move together, and then because we're going to have question and answer at the end.
Okay.
All right.
That's
Sometimes
cool.
as well, we don't want to cut off some people's line of thought. So put down your questions. All right.
Okay.
Yeah. Sorry about that. So we can just go ahead, Paul. So cloud computing essential characteristics. We have on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured services. On-demand services, Paul, Netflix. I'm joking.
Yeah. On-demand services can be anything. I mean, this is on-demand self-service. So
yeah,
as we mentioned before, you can set it up so that so how can I put it? So as an example, you can, like we said with auto scaling or scalability, you can automatically spin up another server or instance i.e. the server with all the applications and services that it needs to run on its own on demand, okay? And it will do that. You can control that as the customer, yeah. You can do the same with every aspect of the cloud: storage, servers, applications. You could have one massive server running and then auto scale the number of services or applications running on that server when it reaches a certain threshold, like we described before. You can also utilize a separate pool of resources, i.e. a separate server for a given period of time. So be it for example, for testing, you can start up a server to run some tests for an hour, and then you can shut it down, and you're only charged for that period of time that you've used it. Okay, so that gives you a little insight into how on-demand self-service works.
Okay. Broad network access. The services available over the network can be accessed via mobile, smartphone, tablet, laptops, and desktop. So it goes back to your YouTube, your Facebook, and co. So all of those applications can be accessed over any of these devices, as long as they are connected to the network. Yeah, Paul?
Or that they're connected to the internet, not the network.
Yeah.
As long as they're connected to the internet, and your applications are built to render
Exactly.
on a mobile or any sort of peripheral device, then the cloud caters for that. So it'll cater for it in the sense of network speeds, service availability, and accessibility as well.
Then resource pooling. Computing resources, including memory and bandwidth, can be pooled to serve multiple customers at the same time, location independent. It goes back to the explanation of having different data center, so they can pool resource to serve. As Paul said, if after 1 second, if it doesn't get a response from that particular data center, it is redirected. That request is redirected to another data center. By so doing, it is pooling resources to serve location independence. Okay. Rapid elasticity. It goes back to the upscaling and downscaling as well. So we have huge traffic on our website. It picks up, it scales and spin up a new machine to accommodate for the memory and for the response and for the RAM. And once the the request goes down, then it downscale automatically. So with that, it is saving you a lot of money. Then measured services. Yeah, go on.
Sorry,
Paul.
can I just add on resource pooling? Another important thing to mention there, which would lead into a more in-depth talk at another time, is with resource pooling, the other advantage that gives you, you can, if you think of it as a house, when you go into the house and you want to go into the front room, if the front room is busy, you can go into the adjacent room quite rapidly by going along the corridor and through the next door. And that's what we mean by pooling resources together. So they're available within a mini environment, so that if the front room is busy, it can quickly be diverted to the second room, which will be able to process everything because it understands everything that's around it. If you're not pooling resources together and it can't get into the house, it will go to the house next door, which may take a little bit longer because it may need to back out of the front garden, go across the road and into the next front garden, then to the door. So it's just important to know that when you're pooling resources together, they're in like the same bucket or same house, and it just makes it easier and quicker for your request to be passed on to another area or another available resource a lot more quickly. That's all I had to say about that.
Okay, measured services or service.
Oh, me?
Up to you, Paul. Yeah.
Yeah, so you can measure the amount of cost or measure the amount of service that you want to use. So not everyone wants everything available 24 hours a day, 7 days a week. They may not have the budget for it. They may not have the need for it. So why pay for something that is not going to be give you a good return on investment? So you have the ability to control the services that you use and when you use them. And that touches on several aspects that we've mentioned about scalability. It also helps you to manage those costs if you're not in the business of leaving them on all the time. So just to give you an example, there's no point in having a test environment up if you're not going to be using it all day long. It's like going into your front room again in the evening when it's dark and switching the light on. When you leave, you switch the light off. You wouldn't leave the light on all day long. So this is just basically what that's covering. The ability to only pay for what you use, hence the example pay as you go, which is fairly common in the business world, and especially at the moment as well.
Tight budget, isn't it? Thanks, Paul.
Tight budgets. Just to give you an example, I've just saved £4,500 this week by managing the costs on my infrastructure.
How did you do that?
I looked at how much, for example, on the storage side of things, I just looked at all of the storage accounts or containers that we had, looked at the size of those storage containers, and looked at an average of how much storage we use in a month over the last quarter, and realized that we were paying for a bigger storage capacity than we actually needed. So I reduced it, and in reducing that, I was able to reduce the amount of processes that we were needing, and that helped reduce the cost. And you do that over 2 or 3.
Which provider is that, please?
I'm with Azure, Microsoft Azure.
Azure, okay. Thank you.
Yeah, you can do this with all of them.
Yeah. So Paul, what you just explained, yeah, I will bring it to for those that have iPhones and the iCloud. You know, iCloud will charge you a specific amount per month. All right. So probably you decide to go for 5 gig or 20 gig, and you're actually using just 15 gig. So instead of you paying for 20 gig every month, say £5 per month, you can now go for the option of 15 gig and pay less.
Yes.
So this is what you can do as an individual, but in a business it's big, obviously. It is the same principle, and obviously iCloud is the same thing, cloud as well, just as businesses use cloud, but in a bigger sense. So that is exactly what Paul just did for the business. He looked at the history and then is able to cut down on unnecessary storage space that we are paying for.
And that's a very good example, David. I can get match that. I used to pay 250 gig for my iCloud storage, which was £5-6 a month. But I only use probably 5. Actually, I think I only use something like 50 gig a month, and that cost me £2.50 or whatever that is. But I managed to reduce that, and I didn't see the point in paying for something that I don't use.
Exactly.
And that's like I say, that's exactly what that is.
Okay, cool. Probably I was reading your mind, or I was watching you doing that as well. I don't know.
Probably was hacking into something.
Yeah, so this is the visual model of cloud computing. So at the very top, we have the essential characteristics. You need the broadband network service, accessory, the rapid elasticity, the measured service, the on-demand service, and all of these you have your resource pooling. Then on the service model, which is the things we're going to cover next, you have the type of services cloud enables. We have software as a service, platform as a service, PaaS, and also infrastructure as a service. And some of the job you've, if for those that have been applying for job, you would have seen SaaS a lot. All right. I believe Sarah is working on a SaaS project, software as a service. She's going to talk later. There's platform as a service, PaaS, and all of this terminology, you see it in the job description. So in the future, when you go search for a job, you see that you should be comfortable that, okay, this is basically what it is about. Then we have the deployment model, public, private, hybrid, or community. So the next thing we're going to be looking at, we've covered the essential characteristics. We're going to look at these service models of cloud computing. Paul, I think I'm going to hand this over to you as well.
Okay, cloud service models. Forgive me, everyone. I will do my best to talk you through this. Infrastructure as a service, or IaaS, is looking at the underlying hardware. So we're looking at servers, we're looking at storage containers, and the networking resources that are required to give you the foundations for your business to be able to be visible on the web. Now, depending on the number of or size of servers and types of storage and databases that you're going to use will determine the underlying infrastructure and what that looks like. There are many different configurations that you can choose from. It's actually can get into a very complex design, but there are tools provided by the cloud providers to help guide you through that. And then that will give you your baseline costs as well. Your platform as a service, or your middleware platform, gives you your technical stack. Again, that's available up in the cloud as well. And that can be, for example, the .NET framework, as an example. You can use that, and you can build your application services using C#. Then software as a service are the applications and software that you build that are available over your network. So things like your web applications or your API services that you would build. Again, written based on the platform that you have, it will be written in the appropriate languages, and then you can do your deployments using the same platform architecture.
Yeah. So let me come in quickly. I was just going to summarize as well. So the IaaS, infrastructure as a service, you know that you used to manage your infrastructure yourself, your server room with the machine, the storage, and everything. So that infrastructure is moved to the cloud. So the cloud have all of those set up in there. You can rent it from there. Then platform as a service could be a particular platform, as Paul said. What platform did you even give an instance of? Let me say in banks, there are middleware provider that have the platform that you can build your service on top, like your banking services. So those platforms will be installed on the application, and you can use that to now obviously build your software, which is what the end users will use. So we are just carrying the server room up to the cloud and then continue business as usual. All right. So this is further description of infrastructure as a service. So which makes the entire computer infrastructure available as a service. So that your server room, that you are managing yourself, all you need to do is to just rent it. It is a service to you. You don't own it. All right. So it says here, manages a large pool of computing resource and uses virtualization to assign and dynamically resize customer resources, customer rent, processing capacity, memory, data storage, and networking resource that are provisioned over the network. So the network, you are paying for the network, you are paying for the memory, you are paying for the data storage. Okay, you are paying for the network, as I say, resources as well. So instead of you having that, you paying Amazon, you paying Microsoft, you are paying other infrastructure provider, and the infrastructure is big business because you have to, it costs millions, if not billions, to have these data centers. Have these data centers are across the globe, and your business is a very small business. All you need to do, you rent whenever you don't need it, you end the contract and then close up for business. If you need to increase capacity, you rent more space. If you don't need more space, you then reduce the capacity you are renting. Okay. Is that okay, Paul?
Yeah.
All right. Should I leave this for you then?
No, you carry on. You're doing tremendously.
I'm confused with this platform, so let me give this. I'm not confused, but you go. Your turn.
Okay, platform as service. So with your platform as service, it's the provision of the hardware and software tools that are provided as part of that service that you can then utilize to run your applications or build your applications and provide it to your customers. It allows you to not only develop, run, but also manage and test all of your applications as well. The service provider is responsible for the maintenance of these softwares and the hardware, and that gives you as the business the flexibility in or the reassurance in knowing that everything that you are using is up to date and current.
All right, so Paul,
Yeah.
you know that the Azure is not infrastructure, is actually the platform on the infrastructure. So Azure is one of the platform as a service because you can use that to provision your machines, upgrade and download, create new instances.
Mm-hmm.
Okay, even AWS as well. I think AWS itself is the platform on. No, I think AWS is the infrastructure, but I think they have the platform is also Amazon something, EC something, which is the platform itself. So the platform gives you an interface, okay, for you to actually access the machine and create new instances as you go along. You guys are going to get to that. Please go Google Azure and AWS or EC. I think Amazon is EC2, something like that. Yeah, EC2 or EC2. That is the platform. It gives you a visual interface. That's why you see this web-like images here. But with if I go back one step, you don't get the web-like image there. But here you have the web-like image. That is where Paul was able to reduce cost because he goes into Azure, he looks at the data that are using, he can now turn off some machine and turn them back on. All right. Then the software as a service, this is where the end users now come in. All right. So service providers is responsible for creating, updating, and maintaining of software and applications. This is basically for our OOS case study. If we had built that, we don't have the server in our local office. We are using Azure. So the actual OS application, we can now access it, and it will be our responsibility to update the application to the software, application, and maintain it. But the service provider will maintain the machines for us. So service users access the service through internet-based interface like your mobile phone, your tablet, and your desktop or laptop. So this is cloud layer architecture. So whatever we've just covered, this is the visual imagery. All right. So at the very top, we have the software as a service, SaaS. We have the platform as a service, and then we have the infrastructure as a service, and then we have the data centers. Now everything must sit on the hardware. So the infrastructure as a service has both the hardware and also the infrastructure. And as I was saying, Amazon EC2, that's what I was trying to remember. Okay, it's part of the infrastructure, go grid and flexibility data center. The data center will hold the CPU, the memory disk, and the bandwidth. The infrastructure will hold the computer and computation like the virtual machines and storage block, and then the platform as a service, where I was saying Azure. Now you can see we have Microsoft Azure, we have Google App Engine, and we have Amazon Simple DB or S3. Okay, Amazon S3. Yes, Amazon S3 is the interface to the Amazon data center or data infrastructure, and we can use software framework like Java, Python, .NET, Storage DB, and Co to manage our infrastructure, our platform. Then we have the actual application, which is like your Google Apps, your Gmail, Facebook, YouTube, Salesforce, all sit on this infrastructure. So this is what is driving us having access to our mobile phone and having access to Facebook and all the software that we have access to. Paul?
I think you covered that one pretty well.
Pardon?
I think you covered that one okay.
All right, cool. So basically, we've covered the main things. And the main things here, there are three key services: platform, infrastructure as a service, platform as a service, and software as a service. This is how we interact with cloud. All right. Now, I don't think this is very important to us, but I'm just going to touch on it a little bit. This is more on the technical people. So the split responsibility. So provide side and also provider side and consumer side. Now, the very first lane is the traditional on-premises. This is where you have all of your infrastructure on premises. You as the client, you manage it yourself. But if you go just for the infrastructure as a service, you will manage the application, the data, the runtime, the middleware, and the operating system, while the vendor like Amazon or like Amazon or Microsoft will manage the virtualization, the servers, the storage, and the network. You'll be paying for that, but this one you manage it yourself locally. Then if you are going for platform as a service, all you need to do, you manage your application and your data. The service provider will manage the runtime, the middleware itself, which is the Azure or EC3, the operating system, virtualization, server, storage, network. And then if it's the full software as a service, then the vendor manages everything for you. They will have someone responsible for that. And the implication is that you might not have your IT manager anymore because you have somebody managing it from the service providers. All right. So what are the benefits of cloud computing to businesses? I'm not going to explain all of these things. I might share this material with you guys later on. The key benefits are cost reduction, scalability, agility and flexibility, and also reliability. Okay. 1 second. Sarah, can you unmute yourself, please, if you can, before you leave? I know you are almost leaving now. Hi, Sarah.
Hello.
Hi.
Hi, can you hear me?
Yeah, I can hear you. Yeah, so
Yeah.
Sarah is one of the people that we've not really celebrated. She started her business BA role middle last month or early last month. Have you done 1 month already, Sarah?
Yeah, I'm 1 month in.
Wow, you are old BA now. All right, so I wanted you to just quickly, even if it's for 2 minutes, 1 minute, quickly touch on your interview and probably what you currently work on.
Okay. I'm sorry to cut the meeting short. It's just I'm actually about to leave. But I would say I'm not from an IT background. I'm from a pharma background. I studied pharmaceutical science. Um, I heard about advanced careers from my partner, and I actually joined, I think, ending of maybe in October. I started my course as a business analyst in October. Um, what did I start? I can't remember when I started. Maybe end of August and then finish in October actually. So I started end of August, finished in October, and then I started applying towards the end of November. But then December is not the best time to apply because of the Christmas break and everyone trying to settle down. Um, but then I got my first role as a business analyst literally last month in February. I currently work for one of the largest leisure center companies in the UK, which has like over 400 sites within UK and outside. I work as a systems business analyst. Um, I did get really, really good training from Advanced Careers, but in addition to that, um, also if you're currently doing a course within Advanced Career, I would advise you to go through the lesson notes, be attentive, go for your classes, jump onto the project, which is really good. I'm kind of like a fast-paced person, so I couldn't really wait for the project. I'm kind of like a go-getter. So I kind of skipped the project and just literally started doing my research and put myself out there on the market. And within 1 month, I already secured a job. So that's my story in a nutshell, really.
Okay. There was something you did that amazed me during the interview. They asked you about OS application, and then you take that, complete that part.
Okay, so one of the if you're doing a business analyst course, and I think maybe if you're doing, I don't know what other courses as well use the ORS system. So as an example, so that's one of the examples you use during the course. And one of the first questions they asked me during the interview was like, all right, you said you've done some training on the ORS system. Open the URL and show me the system. And there is no system. So in my mind, I'm like, if you're Nigerian, I was like, it don't happen. Like everything is gone. Like I've failed this interview. Like what? So the project I'm working on, it's top secret in the sense that you have to sign a non-disclosure agreement. So I threw it back to the company. I said, I'm sorry, I'm still working for the company and um, I've signed a non-disclosure agreement, so I can't show you the website. So that's the way I handled that question.
And skip the question. Well, thank you, Sarah. As you say, you are a go-getter, but you said something. Whenever anyone comes upon this project, you do your own research as well. But I believe what we gave to you was basically was really helpful to help you switch your career. I'll let you go now, and we'll continue. Thank you so much, Sarah.
All right, thank you. Everyone have a good day.
All right, cheers, Sarah.
Bye.
All right, so let's continue. So the essence I brought her in is to just encourage others as well, and probably she can subsequently the past students can share their story and their interview process and how they were able to scale through. Okay, so coming back to the benefit of cloud computing, there are 4 main benefits there, and it is something that we've been talking over and over again: cost reduction, scalability, agility, and flexibility, and also reliability. And these are the things that hosting your site locally yourself has always was a challenge in those days. But these days, every time you go onto the internet, you always have access to that. And these are further broken down into utility, pricing, economy of scale, on-demand provisioning, elasticity, universal access, self-service provisioning, multiple sites, higher availability options, disk recovery, and also security. All right, and they are further broken down into other items as well, but these are the key benefits to businesses. And this goes back to you as a PMBA tester. Every business objective is all about reducing cost, speed, gaining more market share, and going cloud will obviously be helpful to most businesses today, rather than managing that infrastructure themselves locally. So when you get job offers or you're going for interviews and you might need to speak about something related to this, you can see it from the business side and also see it from your own perspective of how you're going to help the business achieve these objectives online. Okay. Paul, do you want to add anything there?
No, only that I think that any company that is not up in the cloud will soon be. The benefits of being up there far outweigh of having something hosted locally. And for sure, all of the big enterprise organizations do have critical systems up in the cloud. The benefits and the cost savings can be huge, but at the same time, you can spend a small fortune up in the cloud. But I think it's cheaper overall because the manpower that you need to manage it can be greatly reduced. It's not an overhead that you would have to use. And also jobs in that area are very highly rewarded at the moment because there aren't that many people that can manage such a enormous undertaking.
Okay, thank you, Paul. Yeah, there are, as Paul just mentioned there, they are paying a lot of people to manage cloud as well, infrastructure managers and co, DevOps and co. It is becoming a new and big area in terms of career. If you have someone young that is willing to bend their head and learn, it is going to be a rewarding career going forward. And if you are here for BA and you want to look at that as well, because you can, even PM or tester, you want to combine these skills with what you are pursuing, that can increase your opportunity also. So importance of cloud computing to development and test. We have high deployment cost to deliver. That is the traditional and the cloud. We have control and governance chaos in software processes, and also on-ramp and onboarding of team reduces time to software delivery. This is the problem that cloud solves. Reduced installation and administration costs, lower TCO, I think it's total cost of operation, by improved utilization of software assets. Okay. Now we talk about, for people that are studying software testing with us, cloud enables automation. Traditionally, you cannot do automation, like automation testing and co. Okay, and it helps with the agile process to run your sprint 2 weeks and deploy quicker. So with cloud, that enables or enhances agile process, better governance through standardized delivery of services, pre-configured software embodying best practice. So you don't have to configure your software locally. These are pre-configured, and that enables speed as well. Then tool can be provisioned in minutes, no download, installation, or setup. So using your own RAM and trying to, as I was giving an instance before, if there's a scale in your website, you need to have a physical machine and set that up. But with cloud, it happens automatically, and then you don't need to download anything. You don't need to install or do any setup. It just copies another machine and start working immediately. And self-administered portal to access to software and resource for a globally distributed team. And that is what Paul says he did. And this is one of the things Paul T does on a regular basis at True Rating currently.
One of many things that I do there.
You are jack of master of everything. Jack of, yeah. All right, cool. So IT benefits from cloud computing. We have some of the items we are looking at: increasing speed and flexibility and reduce cost. So on the left-hand side, we have the traditional and we have the cloud. So test provisioning weeks, it takes minutes to do that. I'll give an instance of automation again. With automation testing, what traditionally will take us 2 weeks to manually test, it will run that test in 10 minutes. And without cloud, you cannot do automation testing. So 10 minutes and 2 weeks. By the time you calculate the salary being paid, or let me say 2 days rather, 2 days regression. No, we used to have 1 week regression testing. So 1 week of my salary, cloud can reduce that time to 10 minutes. You can imagine how much cost the business will be saving. All right. Change management, it takes months, but with cloud, it will take days or hours. Release management, it takes weeks, but it takes minutes with cloud. Service access, administered but self-service. So with service access, you are the one managing your server yourself. You administer the server, but with cloud, it is self-service. That happens automatically. Standardization, it will be complex for you to do that yourself. But with cloud, once you configure the machine, you can copy another machine and copy another machine without download, without anything. It just copies and start working immediately. Metering and billing, fixed cost, variable cost. If your demand increase, you upscale. If demand reduce, you downscale. With that, you are actually paying for what you are using, rather than just paying for a fix, having that machine there on your local environment or your site, which is even more complex to manage. Then reducing cost, server storage and utilization, you are using about 10 to 20%. Just as Paul T said the other time, with his iCloud, he was paying for much more than what he was using. He was using far less. So he was using about that 10 to 20%. If I'm not, am I correct or wrong, Paul?
I have saved 20%.
So
and I've set myself a target to save 25%, but I'm on target to save actually 30%.
All right, so you're actually using 10 to 20% of, let's say you're paying £100, but what you're actually using is just £20. So why are you wasting £80? But with cloud, the variance will be between, you might be using between 70 and 90% of the actual data you require, and payback period will be years, but with cloud, payback period will be months. Okay.
Yeah, with the important thing to remember there with the cost side of things is that it's like with any sort of usage, if you pay as you go, you're only going to pay for what you're using. Whereas at some companies will just set a budget aside and then or just leave all the lights on, and therefore they'll just get billed at the end of it. And therefore you're just, as David says, you're just going to be paying for resources that you're not going to be using 100% of the time. And then that just doesn't make sense, and it's not very cost effective.
Thanks,
You're on
Paul.
mute, David.
Yeah, thanks. All right. Oops. So cloud is an opportunity. Will you be able to take advantage? In summary, technology is enabled. The technology is enabling a smarter planet. We must face head-on the challenges to building an effective IT, and cloud computing is one key way to address the challenges of smarter planet, because you are only using what you need, not just exhausting energy that you are not using. So in conclusion, there's cloud fear largely stems from the perceived loss of control of sensitive data. Current control measures do not adequately address cloud computing, third-party data storage, and processing. Looking to the future, adoption of cloud computing by enterprise will be driven by several factors, including user preference and business priority. Nonetheless, delay in adapting the current law to the cloud era might impede success of this cloud technology. We know about the GDPR and co, but beyond that, I think cloud computing is very beneficial to businesses. Now, we are open to question and answer. I know this tech talk is a bit techy for some people, but that is why it's
Boring.
called that's why it's called tech talk. You know, it's not meant for you to understand everything, but it's meant for you to live here with an idea, so that when you are in the environment, you are not totally lost. Okay. Sorry for my punishing you guys tonight. Yeah, Paul.
Just one thing. When you're in a working environment and you hear a phrase or an acronym that you don't know, and you feel that you don't feel confident enough to put your hand up and ask, write it down and just research it. As long as you understand the basic concept of it, then you'll be fine. After you've used it a couple of times and can give your own example or interpretation of it, you'll be a lot more comfortable.
Yeah. I mean, I've done some training on AWS and all this IaaS, PaaS, and SaaS always get me bored.
I mean, I have a team that will look after my data infrastructure or my data architecture. I have a team of DevOps engineers that will look after my platform as a service, my infrastructure as a service, my my deployment pipelines. But I make a point to understand as much of that as possible, and so that when we're conversing, it's I understand what they're talking about. I mean, this is really low level stuff.
Yeah.
When I'm talking with them, it can get as you have experienced, it can get really detailed, and even sometimes I get lost. It just happens. It's everyone gets lost from time to time.
Yeah.
All right. So, questions. Whoever was writing down.
David.
Hi.
Hello, David. Hello, Paul. How are you? Hello, everyone.
Hello.
Hi, Ayo.
Yeah. Training as a BA analyst, business analyst. How exposed are you, or am I likely to be with this topic discussed this evening? I mean, how related is the BA to this cloud, and how much of it do I need as a BA?
So as a BA, it's not necessary for you to know this in depth. What is important, I think, with anything, is that you understand the basic concepts.
Good. Do you have any BA person on your team? Have you had any BA person on your projects? Any of the projects you've worked on in terms of cloud?
Yes, I have had one. air quotes. I've also taken on, as has David when he used to work for me, that responsibility as well. And they have not had to be involved with that side of the team or that side of the technology.
Okay. Okay. Thank
Can
you.
I say something though?
Let me add
Cool.
let me add first.
Okay.
Ayo, so you will not be involved in Azure most likely, except you are a very technical BA. But when you are putting your requirement, the non-functional requirement, when you start putting down, you want response at a certain time, you want availability of the application all the time. You will start thinking about, okay, there will be the infrastructure, like you can be in a discussion whereby we discuss about, okay, where do we want our application to, which data center should our application point for us to have non-latency or quick response, or how many data centers should we point? So that is where you can now you have idea of what the infrastructure will do and the implication of your requirement on the infrastructure. Okay.
Yes.
So that is where there will be an alignment, but you'll not be in the technical. You might not be in the technical discussion, but if you have this idea, when they come to you, when you're speaking to the technical people, you get a sense of what is happening. Make sense?
Okay. Yeah, I totally understand. Thank you.
Yeah. Is it Samuel? You want to say
Yes,
something?
just to add to what you said.
Yeah.
Usually business analysts do come from different areas, like from data analysis, from technical areas, and from most time business side. So whatever area you're coming from, it's good that when you're leading a project, you understand the jargon that the technical guys are talking about. Because if you're totally lost, they will definitely use you to play. So I believe what Dave is trying to do is to give us like a background knowledge around these topics so that you understand that all these things are there. So because most projects you lead them, you do the requirements gathering and all that, and when a need comes through, you need to understand, okay, this is going in this direction and that direction, and then you'll be able to know what and what is needed before you involve the resource that are required. So it's just background knowledge, like Dave said. Yeah.
Oh.
Okay. Any other question before we round off? Okay. I guess that is it for today. Thank you guys for joining. I was looking at next topic, something around deployment, around branching and co. But if you guys have any topic in mind, you can share it with me, share it with Paul. You can now pick a candidate. But this talk will be boring because it's technical stuff. Okay, it is giving you guys a broader knowledge. That is my goal, our goal, I and Paul's goal for this tech talk. And this is what happens in the industry as well. We normally have tech talk. The more technical people give talks to the non-technical people. Even within the technical people, there are people that are specialists in a particular program or a particular aspect. Someone in the database, we give a talk about database, and a normal developer will say, wow, I didn't even know that exists, But for you guys going into this industry, our goal is to try to broaden your knowledge as much as possible, So we are giving out our time. This is like about 2 hours that we're giving today for absolutely God will pay us, So, but I hope you guys enjoyed it.
Yeah, sure. I did.
Okay.
Yeah, we did. Thank you very much.
Yeah,
You're welcome.
thank you very much, David.
All right.
High up now.
and then so much, learn so much personally.
Okay. So probably I and Paul will look at deployment next. How developers write code on their software and that code is taken to the cloud, and what are the steps that they do. Because in my current project, like the project managers, they talk about master branch, feature branches. Have you moved it to, I need a new build, a new version, version control, but basically understanding the branching and the development process of software. And probably we can also look at web architecture itself as well, just to help you guys broaden your knowledge. But we're going to continue. We'll do this again first Monday of May. All right. Already, I think the event, when you sign up, anyone that signed up for this event, there are other links below this event up till November. So you can also use that to go back to that link and sign up. Please, I'm happy. We want to make this event a free event. So if you have anyone interested or not interested, but they want to know what is happening in IT world, they are free to come on board and join and learn something from it. And probably, who knows, you might be helping them also to transition their career. Paul, do you have a final word?
No, just if whether or not you found this useful for anything, I think it is good to attend things like this in your workplace or how we provide it, just so that you keep up to date with the change in technology around you. It's quite easy to just put your head down and then in a couple of months everything has moved forward so much. Happens to the best of us. Also, I would encourage, if you have anything specific that you want to talk about or you want us to talk about, just send it through. Try and give us at least a week's notice so we can prepare something. The more notice you can give us, the better it is for us. Thank you. That's it.
Thank you very much.
Thank you, guys. Thank you so much. I will share the video later. Yeah, good night. Bye.
Bye-bye.
Thank you. Good night.
Thank you.
Thank you.
Bye, everyone. Cheers.